All the years being spent in school, you've been taught that the Earth is made up of 71% water and 29% land. Having that understanding, it's easy to assume that where a huge body of water is concerned, they're immediately referred to as oceans, being made up of salty water. And that is correct. However, it only applies to a certain extent. You might think that just because the Earth is surrounded by the 5 oceans, it means they're all the same, just mixing with each other, crossing the man-made boundaries in the form of different names given to each part where they're located in the globe. There's the Pacific Ocean, Atlantic Ocean, Southern Ocean, Arctic Ocean, and the Indian Ocean. Among the 5, the Pacific and Atlantic Oceans are the 2 largest seas on the planet, which covers half of the Earth's surface. Now, just because they're both oceans doesn't mean that the 2 mix. Truth is, they don't, at least not in an easy way of you understanding. Which brings us to the question, why the Pacific and Atlantic Ocean don't mix? Did you know that every ocean holds a distinctive, natural border which separates itself from the others? To be specific, a separation is actually present where the Pacific Ocean and Atlantic Ocean meet. But before you immerse yourself in the image of the separation, you might want to hear these things first. That separation is quite invisible to the human eye, and it's not as dramatic as other videos and images have claimed it to be. Contrary to how a lot of videos claim that a visible line exists between these 2 oceans, scientists have revealed that this line occurs when glacial rivers flow out into the oceans. For sure, there have been a lot of viral posts going on about how these distinctive lines are demarcations, indicating where the Atlantic and Pacific Oceans meet, but do not mix. And while this much is true, you can't actually see that physically happening with your own eyes, in the same way that you see oil against water. So what creates these lines? The visible meetup happens as a natural phenomenon. In a research by Ken Bruland of the University of California in 2007, he revealed that this natural phenomenon is not about how 2 oceans meet. Rather, it's an occurrence that takes place when semi-laden water from glacial rivers empties out into the ocean. In his explanation, he said, "Glacial rivers in the summertime are like buzzsaws, eroding away the mountains there. In the process, they lift up all this material. They call it glacial flour, that can be carried out. Basically, as these glaciers melt and get poured out into the ocean, they get picked up by the currents. They then start to move from east to west and start circulating from there. And eventually, these waters end up mixing as they encounter stronger gradients that ultimately envelop them. Later on, those visible divisions will disperse, leaving no trace of the different water that has turned into one. This means that these borders are never static, as they continue to move around until they disappear altogether, depending on the level of sediment and the whims of the water. So the next time you see a video or image with this kind of separation in the water, you know that it's not the point where the 2 oceans meet. They're just a point where 2 different kinds of water meet and eventually mix. Did you just find out about that? Share your thoughts by commenting below. This then brings us to the next question. Do the Pacific and Atlantic Oceans meet? Yes, the 2 oceans meet, but it's not an exceptional sight to behold. What you will just see is a huge body of water, with no lines, no distinction, just all blue water. Now that we've established that, the meeting point between the Atlantic and Pacific Ocean is at Cape Horn. This rugged headland lies at the southernmost part of Tierra del Fuego, an archipelago at the very tip of South America. The waters surrounding the cape are known for its rough currents, strong winds, and unpredictable weather. Knowing that it's at the tip of the archipelago, it doesn't really come as a surprise that navigating its waters would be difficult. Back in time, its waters were untouchable, until 1616, when Dutchman Jacques Lemaire managed to circumvent the cape. Presently, it's now accessible by way of traveling through larger and modern vessels that offer the wildlife view of seal and penguin colonies. Will you be able to tell the difference between the 2 bodies of water? Topographers say that an existent line marks the border between the Atlantic and the Pacific Oceans, which runs straight from Cape Horn to Antarctica, also known as the Drake Passage and Mar de Joses. The Drake Strait is a body of narrow water that stretches between South America's Cape Horn and the South Shetland Islands of Antarctica. It serves to connect the southwestern part of the Atlantic Ocean with the southeastern part of the Pacific Ocean, and also extends into the Southern Ocean. But then, just because it exists doesn't mean that you're actually able to see it. Similar to how some borders don't really have a physical wall which separates two places, the Pacific and Atlantic Ocean's borders are imaginary and determined by scientific grid lines. Now we're finally coming to the part where we get down to the very reasons why the two largest oceans in the world do not mix. Be sure to watch till the very end to find out. If you're discovering something new from watching so far, do give us a thumbs up and hit that subscribe button. Going back to the understanding that the Pacific and Atlantic Oceans are both saltwater and are both huge bodies of water, shouldn't it be safe to assume that their waters are all the same and are only separated by scientific grid lines, and that they should mix because they are basically one and the same? Well, the true answer to that is both no and yes. No, because this doesn't happen in the same instant where the two bodies of water meet. But yes, they do mix, but it takes a whole lot of process and time before they actually mix. It all lies with science, where the water densities as well as the dispersion of currents are concerned. Factor number 1, water density. You would ask, how can they have different densities when they're both waters? A water's density actually varies depending on two main things: salinity and temperature level. A quick note, salinity refers to the amount of salt being dissolved in a sample of water. Remember the formula for density? Density equals mass over volume. Based on the common formula, density is in equal proportion to mass, and when there is more salt in the water, its density changes as the water's mass increases. Keep in mind, the greater the salinity, the greater the mass, which results in having water with a high density. A simple example of this would be to have two clear bowls of the same size that contain the same volume of water. One bowl will have less salt and the other with more salt. After doing this, put an equally proportioned egg in each bowl. Then observe what happens. You should see that the bowl with the greater concentration of salt has made the egg float better compared to the other. On the other factor of temperature, when water is heated, it expands, which results in an increase in the volume, with the way that density is inversely proportional to volume. So where there is greater volume, density lowers. As you compare the two samples of water that have the same level of salinity, you will find that the water with higher temperature is less dense. Factor 2. Dispersion of currents. Every ocean has a distinct dispersion of currents, which take place on both the surface and the deep water movements. Imagine this: two unstoppable forces going in different directions. Are you able to catch the wave now, which explains how difficult it is for these water bodies to come together? Ha ha ha. Pun intended. There is definitely a lot of mixing going on between the two oceans, but the rate of mixing isn't strong enough to completely homogenize the water. The process of mixing the water can get really complicated when you delve into it scientifically. There is actually one more factor that needs to be considered in this discussion, which is the bonus factor, rate of mixing. With this final factor to consider, the fluid system comes into play as it measures the level of mixing required in order to mix water properties as big as the ocean. This factor takes up the volume scale and time scale, with this as the main formula. Rate of mixing equals volume scale squared over time scale, where the rate of mixing is directly proportional to the square of the volume scale over the time scale. It implies to consider the size of the fluid parcels in a given time. This means that as the volume of water increases, it also increases the time it takes to mix the water masses. So, in the effort of completely mixing large bodies of water like the oceans, and also taking into account their different chemical and physical properties, the whole process of mixing will take a very long time. How long, you ask? About a millennium. Yes, it takes about 1,000 years for the oceans to completely mix. That's how massive the oceans are. Come to think of it, the notion that humans know more about outer space than the deep blue oceans is indeed very realistic. If you found this video interesting, please give us a thumbs up and hit that subscribe button, or you're going to get a notice of suspension.